All right. Okay, so the first lesson that we're doing today. First lesson of the year. This lesson doesn't have any adding, subtracting, multiplying, dividing. You don't need a calculator for this. I always start it that way. I always like to do it that way because it kind of eases you in, right? It's called graphing stories. It's a story in words. The top is a story. Example 1 is a story. It's a story about snow falling during a snowstorm, okay? So in math, we have pictures. It's not like in English class or, in history class where you have pictures of, whatever you're studying. Or English class, you have pictures of the story you're reading. In math, the pictures are graphs. It's just a picture. It just visually shows. A lot of you said, Mr. Flores, I like it when teachers can make it visual, right? Because it's easier for me to see. Sometimes math is hard. That's what graphs are. Graphs are that. Okay? So we're going to start with this, okay? So what I'm going to do is so I have some steps on the board here. How are we going to do this? 3 steps. First step, we're going to go slow, especially on the first one. I want to go slow. I don't want to go too fast. Some of you might be like, I get this. I kind of get this. Then go faster than me. It's always okay to go faster than me, okay? Especially if you're like, I know how to do this. Go faster than me. I don't mind that, okay? If you get stuck, then you can wait for me. Go slow. We're going to do one set of directions at a time, okay? We're going to make as many dots on the graph as possible because you make more dots, it'll help you see the picture, right? Last thing we're going to do is connect the dots. Okay, so the first thing we're going to do is slowly we're going to read the directions. We're going to read the instructions. These are a set of instructions. It's the story. So the first one, during a snowstorm. Okay, during a snowstorm, Easton tracked the amount of snow on the ground. It doesn't snow in Fresno. Okay, or it rarely snows, and if it does, it's just by the time the snow hits the ground, it melts. So, but in other places, in the mountains, other places around the country, it snows. So they measure how high the snow is, how high the snow gets. Well, that's what happened here. Okay, so first sentence, not really anything, just kind of giving us background. Second sentence, when the storm began. Okay, so at the beginning of the storm, there were 5 inches of snow on the ground. Okay, so there we go. Now we have our first set of instructions here. When the storm began, there were 5 inches of snow on the ground. So let's go down to our graph. Our graph has 2 things. It has an x-axis and a y-axis. The x-axis is time. Time since the storm. 1 hour, 2 hours, 3 hours, 4 hours, so on and so forth. The y-axis, up and down, measures how high the snow is getting, right? How high the snow is getting. Okay, so at the beginning, they said at the beginning. What hour is at the beginning? Represents beginning. 0, right? 0, right? The storm hasn't started yet. It's right when it starts. That's 0, right? So at 0 hours, how high is the snow? 5 inches. That's going to be our first dot. 0 hours, 5 inches. So we're going to make a dot right there. That's the start of the storm. Okay. All right, let's go to the next one. Keep reading the story. Okay, after that, snow fell at a constant rate of 3 inches per hour until another 6 inches had fallen. Stop right there. Let's break that down. Okay, let's start with constant rate of 3 inches per hour. If something is, so what does that mean, 3 inches per hour? What does that mean if something happens at 3 inches per hour? Snow is falling at 3 inches per hour. What does that mean?
Every hour, 3 inches is added.
Exactly, perfect. Every hour, snow goes up 3 inches, right? So snow is increasing, so it's going up, right? So every hour, snow is going up 3 inches. Perfect. How long is it doing that? Until it gets another 6 inches.
So 2 hours?
So, where do we need to go? How many inches are on the ground right now?
5.
So another 6 inches would be how many? 11, right? So we need to go to 11. 11 is right there, right? So we're going to go from this dot up to 11. So it's falling 3 inches every hour. So the inches is up. So I got to go up 3. 1, 2, 3. How many do I go over?
1.
Because it's 1 hour, right? Yeah, good. I'm not there to 11 yet, right? So I got to keep going up 1. Up another 1 till I get to 11. Now I'm at 11. So it was 2 hours. Yeah, it was 2 hours. Like Matthew said, it was 2 hours. Okay? Stop right there. Okay? Let's go to the next one. So we got this. Okay, so now we're on the next sentence. The storm then stopped for 7 hours. So if a storm stops for 7 hours, what's going to happen to the snow? Is it going to go up, or is it going to go down, or is it going to stay the same? Stay the same. Yeah. So another person in my class said, doesn't it go down? It only goes down if the sun comes out, right? If the sun melts it. And it didn't say it's melting it. So it's going to stay the same. Okay. So right now, it's been 2 hours, and it's 11 inches high. For the next 7, is that what it said, 7? Do I remember? 7 hours, it's going to stay the same. So what does that look like, stay the same? It doesn't go up, doesn't go down. Yeah, flat line, right? A flat line. It's going to flat line for 7 hours. So 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6 hours, 7 hours, it's going to flat line. It's not going to go up or down for 7 hours. It's going to stay the same. Because the snow didn't go up, it didn't go down. Okay, good there. So far we're at 9 hours. We're at 9 hours and the snow is 11 feet high, or 11 inches high, sorry. Okay, so I got this part. Then it starts again. It's going to start again at a constant rate of 2 inches per hour. So that means it's going to go up 2 inches every 1 hour, right? For how long? 2 hours. So we're going to do that for 2 hours. So we're going to go up 2 inches every 1 hour. That's 1 hour. That's 2 hours. Right? Each of those dots represents an hour. So in 2 hours, it's going to be, so we're at 11 hours since it started, and we're 15 inches high. 15 inches high. Okay. We're there. Okay. As soon as the storm stopped, so the storm's stopping again, but the sun came out. So right when the storm stopped, the sun came out. Sun melts snow. So which way is it going to go? Is it going to continue to go up? Down? It's going to go down because snow is melting, right? It's becoming water. As soon as the storm stopped, the sun came out and melted the snow for the next 4 hours. So right now we're at hour 11. So it's going to go until we get to hour 15. Okay, how fast was it melting? 2 inches per hour. So this time we're not going to go up 2 inches. We're going to go down 2 inches, right? We're going to go down 2 inches. So we're going to go down 1, 2 over 1. That's 1 hour. Down 2 over 1. That's 2 hours. Down 2 over 1. That's 3 hours. 1 more hour. Down 2 over 1, and that's the 4th hour. Because it said 4 hours, so 2. So how much, so it went down 8 inches in those 4 hours, right? So right now, there are 15 hours since it started, and total there should be 7 inches of snow off the ground. All right, let's go to the next step. That's it, right? It said make a graph. Well, each of those dots represents a graph. That's when we do step 3. Step 3 is connect the dots. So you can use your notebook, the edge of your notebook, to make straight lines to connect the dots. We start at the beginning and we go up. That's one dot. That's one line there, and then it stopped first 7 hours, and then it went up for 2 hours, and then it went down for 4 hours, right? And that's the picture. That picture represents the story. It tells exactly what happens, except there's no words. At the beginning of the storm, there was 5 inches of snow already on the ground. Then for the next 2 hours, 3 inches fell every 1 hour. And then the storm stopped for 7 hours. And then for the next 2 hours, 2 inches per hour happened of snow fell. And then the last 4 hours, it melted, right? It melted 2 inches per hour until we got there. So on a test, I could ask you this. I could say at the end, how many hours had passed and how many inches were there? 15 hours had passed, 7 inches left. Okay? To answer that question, you would have to do the whole graph, right? You would have to do the whole graph. You couldn't just go right from there to there. So that's why I would ask you that question. Okay? That's an example. All right, now there's another example, number 2. Let's turn it over or open it up on the inside. And number 2, Brianna and her, she's driving a couple places. Okay? So instead of snow falling, she's driving. So it's not going to be the same, but so look at the graph. What part of the graph is the same as the last one? The time on the bottom, right? Yeah, time's always on the bottom. Why is time on the bottom? Because I can't control time, right? It's 11:12 right now. I can't stop time right now. It's going to go to 11:13 and 11:14. That's just the way time works. So because I can't control it, we call it independent. It's independent, right? When you guys turn 18, you guys become independent. Your parents can't control you, right? If you want to do something, you can do it, right? That's kind of like what this is here. It's independent. But I can control how far I drive, right? I can control that. So that's why this is the Y. That's why they call the dependent. The Y is the dependent. Okay? So time is in minutes. So now it's not the height of the inches of snow. It's how far away from her house is she? How many blocks? They use blocks. They don't use miles. In Fresno, we'd probably use miles, right? But this is probably a bigger city like San Francisco or one of those cities. Fresno's too spread out. Like cities like San Francisco are like right on top of each other, so they use blocks instead of miles. Okay? Okay, so let's read the story. Brianna left her home at time 0. Okay? So at time 0, how many blocks away is she from her house? 0. She hasn't left, right? So our first dot is going to be at 0, 0. She hasn't left. If she hasn't left, she's at home. She's 0 away. Okay, next one. Then she drove for 2 minutes to the store. We know it's going to take 2 minutes. How fast is she driving? 5 blocks per minute. 5 blocks per minute. Okay, so from that dot we just made. After 1 minute, how fast is she going to go? How far is she going to go? 5, right? Because she's going to go 5. So we're going to go up 5 blocks. That's how much she's going to cover in 1 minute. And then over 1 because it takes a minute. She does that for 2 minutes. Now I'm at 2 minutes. I'm 10 blocks. She's 10 blocks away from home. Okay. All right, let's keep going. Then she stopped and went into the store for 4 minutes. So for 4 minutes, so from 2 minutes to 6 minutes, that's 4 minutes, right? She stopped and went into the store. She's not in her car anymore. So how do we show that on the graph? Yeah, just go straight over 4, right? Flat line. It's kind of like when the storm stopped, that idea. So yep, you just go over 4. 1, 2, 3, 4. There we go. Perfect. She's in the store. Then she comes out of the store. From there, she drove in the same direction. So which direction was she driving before? Away from her house or towards her house? Away. So she's going to continue doing that. She's going to continue going away from her house. Okay, so how far is she going to go? We know 15 blocks away, right? So it says, let's read this next one. From there, she drove in the same direction at a speed of 5 blocks every 4 minutes. Up 5 over 4. Up 5 over 4. How long are we going to do that till? Until she gets 15 blocks away from where she is right now at the store. She's at the store right now. Let me write that in. She's at the store. So she's going to go 15 blocks away from the store. How many blocks is she going to be from home then? 25. There you go. If she's 10 away right now, and she's going to go another 15, that's 25. So now we got to get to the top. So we got to get to the top. How fast am I going to get to the top? 5 blocks every 4 minutes, right? That's what it said. So 5 blocks means I'm going to go up 1, 2, 3, 4, 5 in 4 minutes. Make a dot. That's 1 dot. I'm not there yet. I got to get up to 25 blocks. So I'm going to go again. 1, 2, 3, 4, 5. 1, 2, 3, 4. Here's another dot. I'm not there yet. I got to get to 25 because that's 15 more than where I started. 1, 2, 3, 4, 5. There we go. 1, 2, 3, 4. There we go. Now I'm finally there. 15 blocks away from the store. Okay. She stopped at the bank. That's the bank. Okay, that's the bank. She stays there for 2 minutes. Just like she did at the store, right? We flatlined at the store. She's going to flatline another 2 minutes because she's in the bank. So 1, 2. Last thing she's going to do, she needs to drive back home. To drive back home, she's going to have to change direction, right? There's no way she can keep going in that same direction and get home. If you're driving away from something, like if I'm moving away from my desk here, there's only one way to get back to my desk. I have to turn around, right? So I have one question. Where's home on the graph?
0.
0, right? Home was right. This was home right here, right? This was home here. I can't go back in time to get back to 0, 0, but what I can do is get back to this line, right? This line, this x-axis represents home. So I need to go from this dot to home. Okay? So how fast am I going to do that? She's coming back home at 5 blocks every 1 minute. She's able to go faster this time than she was going. 5 blocks every 1 minute. So 5 blocks. 1, 2, 3, 4, 5 every 1 minute. Here's a dot right here. She's coming back home. That's why she's going in the opposite direction. 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. She's almost there. 1, 2, 3, 4, 5 over 1. Now she's finally home again. She's finally home again. Took her 5 minutes to get there because she started at time 20, ended at time 25 minutes. Okay. Last step, connect the dots. There you go. She started at home, she finished at home. So before we go on to the next one, so you remember back in when you were in 7th, 8th grade, if you can remember that far back, and then even when you were in Math 1, whenever you took Math 1, do you remember your teachers bugging you about slope, rise over run, y equals mx plus b, all that stuff? This is the reason why. That's all that is. All of those, see those little up and down, those little black marks there? That's all rise over run. That's all slope. Slope is how fast you're doing something. That's all it is. That's all slope was, right? That's why we come back to it now. We're coming back to it in Math 3. You know, back then they would make up equations and say, what's the slope? Now it's a story because it all comes back to real life. This is you guys right now. However you guys got to school, whether you drove here, whether you got dropped off, whether you took the bus, this is you guys right now, right? Instead of going to the store, you came to school, right? And right now, what are you guys doing? Flatlining, right? You're flatlining because you're not getting closer to home or you're not going further than home, you're flatlining. 3:35, you get back on the bus or you get back in your car and you go home. Okay? That's your story every day. That's what you guys do every day. Okay? All right, so what I want you to do now is try number 3. Number 3 isn't about a snowstorm. It's not about Brianna driving her car. It's about temperatures. Temperatures going up and down. Okay? So try to make as many dots as you can. If you can get them all, great. If you can get 1, good. If you can get 2, better. If you can get 3 better than that, go. We'll go over it, but I just want to give you guys a chance to try one on your own. Try number 3 on your own. Okay, so at 6 a.m., the temperature was 56 degrees Fahrenheit. That's my start. Okay. After that, for the next 2 hours, the temperature rose 2 degrees per hour. 2 degrees per hour. So for the next 2 hours. So right now I'm at 6, right? If I go 2 hours, that's 8. So every hour, it went up 2. So I'm going to go up 2 degrees, 1, 2, every 1 hour. That's 7, right? So I'm going to go one more time to get to 8 because it said 2 hours. Okay. For the next 9 hours, it went up 2 degrees every 3 hours. Okay, so we're at 8 o'clock right now, 8 a.m. 8 a.m. So 9 hours. So 9 hours is going to be, let's see, 9, 10, 11, 12, 1, 2, 3, 4, 5 o'clock. So from 8 a.m. to 5 o'clock p.m., it went up 2 degrees every 3 hours. 2 degrees every 3 hours. So that's up 2 over 3. Up 2 over 3. Till I get to 5 p.m. And there I am. That's 5 p.m. right there, right before 6 o'clock. Let's see, yep, right there. 5 p.m. Okay. That was the next set of directions. Because it said it went up 2 degrees every 3 hours. So not every 1 hour, every 3 hours it went up 2. So that's why I went up 2 over 3. The temperature's still going up. Just like right now, temperature's going up. Right? Temperature doesn't usually come down until the late, almost evening, when the sun starts to go down a little bit. Okay? Okay, so now, from there, the temperature stayed steady until 6 p.m. Stayed steady means stayed at whatever it was. Right now it's 5 p.m. and it's 66 degrees. So it's going to stay 66 degrees for one more hour till it gets to 6 p.m. Okay. For the next 3 hours, it dropped 1 degree per hour. So the next 3 hours, so 7, 8, 9 o'clock until 9 o'clock p.m., it went down 1 every hour. Down 1 over 1. Down 1 over 1. Down 1 over 1. 8, 7, 8, 9. Okay, I'm at 9 right now. Yeah, I'm at 9 p.m. That's 3 hours from 6. Okay, so I'm at 9 p.m. right now. Okay. Then it drops steadily until the temperature was 62 at midnight. So the end is going to be 62 at midnight. That's the very end, they told me, 62 at midnight. So at midnight, it's going to be 62, so that's right there. That's 12 a.m., 62 degrees Fahrenheit. Right? Fell steady means it's fallen one line, just a straight line. So from there to there, it's going to be one straight line. Done. And that was the last thing that we got to do for this graph. So now the last thing, draw my connect the dots. Again, tells that story. This is every day. This temperature is very nice. This is probably on the coast somewhere. This is not here. But we do the same thing. Ours would probably be like this, right? Because this morning, it was in the 60s. Now it's in the 80s. So our graph, if we're talking about Fresno, our graph increases a lot more. Started at 62 this morning, so it would be like, I mean, we would need to go up to 80 something, so like it would be like that, right? Our graph is a little more drastic than this graph. Like I said, this is probably on the coast. On the coast, the weather stays the same. On the coast, it's going to be in the 60s. If it's winter, it'll be in the 60s. If it's summer, it'll be in the 60s, right? Okay. All right, so the last thing we're going to do is they give you the graph. For number 4, they give you the graph. What they want you to do is answer the questions about it. Okay, answer the questions based on the graph. So now they've given us a graph. They don't give us a story because it's already there. So at 6 a.m., it was 54 degrees. Then it rose till afternoon. And then it stayed steady, then it fell some more. Okay? So let's answer some questions. First question, how hot was it when it held steady? 65 degrees. 65 degrees Fahrenheit. When it held steady. So held steady means doesn't go up, doesn't go down. Okay, next one. How much did the temperature increase per hour from 6 a.m. to 9 p.m. or 12 p.m. Sorry. So let me go look at this one, guys. From 6 to 12. So 6 a.m. is that dot. 12 p.m. or noon is that dot there, right? So it was at 6 a.m. it was 54, right? At noon it was 62. So what is that, 8? It went up 8, but they don't want just 8 degrees. They want to know hours. So that was up 8 degrees, right? It went up 8 degrees, but how long did it take to go up that 8 degrees?
6 hours.
6 hours, right? So how do we write that? We write it as a fraction. We say 8 degrees Fahrenheit in 6 hours. Can I divide those to make, does 6 go into 8 evenly? No. So what do? Reduce your fractions. What's the biggest number I can divide both 8 and 6 by? 2. So divide them by 2. The top one becomes 4 degrees Fahrenheit. The bottom becomes 3 hours. And that's your rate. It went up 4 degrees every 3 hours. 4 degrees every 3 hours. So increased 4 degrees Fahrenheit every 3 hours, or let me write it as a sentence. Every 3 hours. Okay. Letter C wants to know the same question except different time. So it's going to decrease from 6 to 9. Well, let me go find 6 and 9. 6 p.m.'s right here. 9 p.m.'s right here. So yellow to yellow. So that's 3 hours, right? So how much did it go down every 1 hour? Or how much did it go down from yellow to yellow? It went from 65 to 59. So it went down 6, right? So it went down, so we say 6 degrees Fahrenheit went down. How much do I go over? Why did I do that? So I went down 6, and I went over 1 to 3 hours, right? So again, I have 6 degrees Fahrenheit divided by 3 hours. Can I divide that? Does 3 go into 6 evenly? Yeah, you can divide them both by 3 as well. You can divide them, they both can be divided by 3, right? So the top is going to be 2 degrees Fahrenheit. The bottom is going to be 1 hour because 3 divided by 3 makes 1. So went down, decreased 2 degrees, every 1 hour. Okay. How many times during the day did the temperature reach 60 degrees? 60 is right here. That's 60 degrees right there, that line, that red line there. So it hit 2, right? It hit right here, and it hit right here. So what time was it? Let's see. So when it crossed, it was right there. So it's like right in between here, right? So let's see. Yeah, I think it's 10:30. 7, 8, 9, 10:30. Yeah, because right there, it's going to cross. So 10:30. And then over here it crosses 7, 8:30. 10:30 a.m. So we say twice. At 10:30 a.m. and 8:30 p.m. And we're done. Okay. So after we're done, you're going to take the same tape